going to look at solving equations using logarithms or using exponentials, depending on the equation that we're trying to solve. We are using the enVision's Algebra 2 book. This is topic 6, lesson 3, example 5. A key little fact here is I recorded this video yesterday and then it crapped out of me towards the end. So hopefully I will remember everything that I recorded yesterday and tie what the other notes have to this one. So the first one we're going to look at is 25 equals 10x minus 1. And remember that this 10 is my base. And we call it the base because we're trying to keep my exponent grounded. We want to keep it part of the equation. So I cannot just divide 10 out of here because this piece right here will just go floating up into space. So the first thing I look at here is I'm like, okay, well now I don't know what to do because I can't divide out the 10. So what we're going to do is we're actually going to log both sides, because remember, what you do to one side, you must do to the other. So I'm going to take the log, the common log of both sides, which leads us into another log property. So if I have the log of base b of, I don't know, let's a letter z to the x, then I can actually rewrite this as x log base b of z. So I could take this exponent and move it to the very front of our logarithm, and I could multiply it. I can make it a factor to our log. So that's what I'm going to do over here. I'm going to take this x minus 1, I'm going to move it to the front. Alright, so now I have log of 25 equals x minus 1. Keep that in parentheses because that is a group. Those do belong together. Log of 10. We talked about when we have a log base with the same output, so log base b of b. This is 1, because in other words, you could say b to the power of 1, b to the power of 1, is equal to b. So my log of 10 simplifies to 1. So now we have 1 times x minus 1, which is just going to be x minus 1. All right, so log of 25 equals x minus 1. Isolate x by adding 1 to each side. All right, this would be the more precise answer. This would be an acceptable answer to leave this in, but I'm going to give the approximate because it's always great to practice on your calculator to find your buttons and get familiar where buttons are. So I'm going to put it in log 25 and I get 2.398. This is an approximation. This is not exact. So x is approximately 2.398. So just again to reiterate this, 10 is not a coefficient. It is a base. It is the value that is keeping the x minus 1 tied to this equation or the expression. So you cannot divide out by 10. That is a common mistake, and I actually have seen that happen quite a few times. All right, so let's look at another one. So we've done trying to solve for an exponent by using logs. Let's look at the natural log of 2x plus 3 equal 4. Well, there is a property that says your base log of base of, I don't know, let's just do x, is equal to x. My base in a natural log is e, so if I say that this is e, or Euler's number, raised to a natural log of 2x plus 3 equals, and when I do to one side I must do to the other, e to the 4th, then I can use this property right here and I can take 2x plus 3. So now I have 2x plus 3 equals e to the fourth. Isolate x, so I'm going to subtract 3 from both sides. 2x equals e to the 4 minus 3. Divide by 2. And I get x equals Euler's number to the fourth power minus 3 divided by 2. Okay, so this is the precise answer. And the approximate answer, again using a calculator to find this, is going to be approximately 25.799. So again, you can go back and forth. I could also just convert this as well. My base here is e to the power of 4 equals 2x plus 3. E to the power of 4 equals 2x plus 3. And I could actually skip this step right here. That basically just skips that step and takes us right down there. All right, so this is the end of these examples. I will do one more example just so you guys can see this. But I'm going to do ex plus 2 equals 8. This is one of the triads, and I was seeing this as I was going through everything. I'm going to do the natural log on each side. Because again, I'm going to do that log base b of b of x is equal to x. So here I have log base e of e. Move that to the front, so I have x plus 2 natural log of Euler's number equal natural log of 8. This becomes 1. So we have x plus 2 equals natural log of 8. X equals natural log of 8 minus 2. And plugging this in, natural log of 8 minus 2, I get approximately 0.079. And there you go. So just different ways to use the natural logs or exponentials to solve for basically their inverse function. So you're using the inverses to solve for x. All right, guys, if you have any questions or comments, please feel free to contact me, and I will see you in the next video.